Hey, okay, so this is the building macromolecules activity that we're doing, and take a look at this, see if you can figure out what it is, and make sure everybody has a document that looks just like this. So if not, pause the video and pass one out, and yours may be different colors, but that's okay. So go ahead and pass these out. Okay, so look at it, and go ahead and count the carbon. So count the C's, and you should see, and y'all go ahead and write on yours. That's okay. So you should see that there's 1, 2, 3, 4, 5. If I can count right, yes, I can. There's 6 carbons. Okay. Now you go ahead and count the hydrogens. Okay, if you counted right, you should have counted 12. Okay, so make sure you count that one twice. 1, 2, because there's a little 2 beside it. So that's 2, 3. Let's go with a different color. Maybe that would help us out. Okay, so we're going to go, hydrogens are going to be green. Okay, so you got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep, there's 12 hydrogens. And hopefully yours looks a little neater than mine, because mine's looking messy now. Okay, and then if you count the number of oxygens, so take a second and do that, you should have 6 oxygens. Okay, so the molecular formula of what we have is C6H12O6. Okay, so that's glucose. That's what glucose looks like. 6 carbons, 12 hydrogens, and 6 oxygens. So go ahead and write on your paper somewhere that this is glucose. So label yours. Okay, so what you're going to do at your table is you're going to take a pair of scissors and cut down this dotted line. So you're going to cut off the hydroxyl, and you're going to cut off the hydrogen. So go ahead, pause the video. Do that for a second. All right. Now, you can tell right here on this side, you have an open bond. So the OH is gone on your paper, and there's an open bond now. Well, that open bond is going to bond to something else. And so take glue or tape, whatever's there, and you're going to tape together your glucose, your monosaccharide, mono 1, that's 1 glucose, with the peoples at your table, the people in your group. Okay, so you're going to tape them together along that dotted line, but don't lose those little pieces, because that OH and H right here, if you look right here, this OH right here and this H right here, that's water. That's H2O. So you're going to tape it together, but you're going to tape the H and OH and tape it on a water droplet and show how water came out when you bond it together. And so water was removed. Water was removed. And think for a second what that process is called. That's called dehydration, the removal of water, and you're building a molecule. So when you tape those together, you're building a molecule. Okay, and I want you to think about when those bonds go together, that's energy being stored. So energy is being stored in those bonds. Okay, let me show you something else right quick before you get started. Don't start taping yet. Okay, so it should look, let me scroll down. When you get it together, I want it to look like this. So water's coming out or coming down. And you take the H and OH on there, and it's coming out. So go ahead and do yours at your table. And then what I want you to do is at all the tables, put them together and just line them up in the floor so we can see a big polysaccharide, many sugars. Okay, so pause the video and get to taping. Hey, you're back. Okay, so now we're going to do the same thing. Dehydration synthesis, remove water, building bonds, but with a fat. Okay, so if you look right here, and I have my documents lined up side by side. So if you look right here, this one is your glycerol. So go ahead and label it. Glycerol. And over here, that's your fatty acids. Now, think for a second. Is that saturated or unsaturated fatty acids? And if you're thinking saturated, that's right. Okay, so what you're going to do is you're going to remove the water again and tape the little water drops in. But you're going to take this one and put it here. And this one and put it here. And then let me show you an unsaturated fat. Right. Okay, let me show, those are saturated fats. Let me show you right here an unsaturated fat. And so you can see a hydrogen's not on there. So you're missing a hydrogen right there and right there. So there's a double bond and it's crooked. So this is like the phospholipid leg that's sideways. So go ahead and tape your piece that looks like this to the bottom of the glycerol. And it really doesn't matter if you have 3 saturated fats or whatever. Just go ahead and make you're making a triglyceride because there's 1 glycerol and there should be 3 fatty acids. So wait, before you start, give me a second. It should look something. It's going to go like right there. And then you have 1 right there and 1 right there. And make sure to put the water droplet again for me. Okay, so pause the video. Go ahead and start that. All right, now we're on to proteins. Okay, so when you go to make your protein, take a look at this is an amino acid. And remember, amino acids make up proteins. Amino acids make up proteins. So when you look at your amino acid, we're actually going to label this. Okay, so this is your amino acid. Ooh, that's too big. Okay, now we have on this side an amine group. So I want you to label that, like put a box around it and then write the word amine under it. Okay, and over here we have a carboxyl group. So take a second and do that. Up here we have your alpha hydrogen, your central carbon, and this is possibly the most important part. So I want you to take and maybe highlight or outline or whatever that bottom part. And yours probably looks different than mine. That's what we call, and you can label this, your R group. So that's what we call your R group. And there's 20 different R groups that can attach right there. So amino acids made up of an amine on the left, a carboxyl on the right, and then an R group which attaches to the bottom. And that R group really, really, really helps determine the function of that protein. Okay, so I think you know what to do. We're going to take the hydrogen and the hydroxide off, put water, tape it together, and you're going to do the whole classes again just like you did the sugar. And so this amino acid is going to make a big protein. Okay, another word for protein, and you'll know this in the notes, from the notes. Another word for protein is polypeptide. Many peptide bonds. So when you take those amino acids together, you're making the covalent bonds between the amino acids. So amino acids join together with covalent bonds, and the name of the covalent bond is a peptide bond. So the word polypeptide is another word for big protein. It's the same thing. So go ahead and make your polypeptide as a class and line it up. All right, so we're on to DNA. Okay, so you have the adenine bases here. So when you look at this one, this is a nucleotide, which makes up DNA. So this is a nucleotide, and in the nucleotide, you can see the phosphate, that negative charged phosphate, the 5-carbon sugar, which in DNA is deoxyribose, and then the nitrogen base, and this was adenine. So remember that adenine pairs with thymine, and cytosine pairs with guanine. Okay, so look at which nitrogen base you have. Okay, and I want to review a couple things about a nucleotide. So this is one nucleotide. A phosphate, 5-carbon sugar, and then the nitrogen base. Right here is what we call a phosphodiester bond. Okay, so it's a covalent bond called a phosphodiester bond. And then where the A and T pair together, that will be a hydrogen bond. So here's this yellow right here is the hydrogen bond. Okay, so go ahead and find someone at your table that has a matching base pair, and y'all pair them together. And you'll tape them together, and we're going to make a long strand of DNA. But a couple of things I want you to know about DNA. DNA is made up of nucleotides. DNA is let's go with a pen. DNA is anti-parallel. And what that means is that one of the strands runs upside down because that's the way it bonds. So anti-parallel. And remember that DNA holds the instructions to make proteins in your nucleus.